Hello guys! We are from Calculus 1, Group 6, Actual Science, Batch 2023. In this video, we will discuss about
The application of calculus 1 in real life, in particular about derivatives.
But before that, we will introduce ourselves, and after that, we will straight jump to the video.
Slick back. No, slick back. That's what I said. Slick back. No, nigga, I'm a pimp named Slick back. Pimp named Slick back. Pimp named Slick back. Nigga, are you deaf? I'm a pimp named Slick.
I am Eunike Aprielle. I am Ivana Felixia Suharsono.
Hi, my name is Tania Kurniawan.
Hi, my name is Nur Farida.
Hi, my name is Auriellia Kusmanto.
Hey guys, so we studied calculus, right, for our semester. What is calculus?
Calculus is one of the branches of mathematics that includes limits, derivative, integral, and infinite series. Calculus is the study of chain, and its application can be used widely in many fields, such as engineering, science, and economic. It can also be used to model systems where there is a chain. Calculus has two main branches, differential calculus and integral calculus. For semester 1, we study calculus 1, which is about function, limit, and derivative, and we will continue about integral in calculus 2.
Oh, okay. What material is studied in calculus?
Now we learn about derivatives and its application, such as minima, maxima, stationary point, monotonicity, and concavity. The derivative of a mathematical function defines the rate of change at a specific point, such as the rate of change of velocity in vehicles. Integration is the inverse process of differentiation. In derivatives, the degree of the function gets smaller. However, in integral, the degree of the function gets bigger.
So, what can derivative be used in real life?
So one of the most common application of derivative is determining maximum and minimum value. In our daily life, we can use derivative to determine the velocity and acceleration of a certain moving particle or vehicles. This is widely used in physics and engineering because producing ships, aircraft, and other vehicles also involve the use of derivative.
For the application, we use derivatives to determine the velocity and acceleration of a certain moving beam bicycle, which looks like this. So now we are about to discuss how to determine velocity from distance function, and also why is velocity the first derivative of distance. If we have s equals to ft is the equation for the movement of a certain particle with s in meters and t in seconds, then we can have this graph. This is when time is equals to 0, this is when time is equal to c, and this is when time is equals to c plus h. When we substitute c to the function of s equals to ft, we can have that the distance traveled during c seconds is equals to fc, and the distance traveled during t equals to c plus h seconds is equals to fc plus h. So the distance difference between t equals to c and t equals to c plus h, we can denote it by f c plus h minus fc. Next, we can determine the average velocity with the formula of v equals to s over t. This is the delta s, or the difference in distance, and this is delta t, the difference in seconds. So when we substitute from the earlier function that we have, we can get f c plus h minus fc over c plus h minus c. This is for the difference. and we simplify it and it will become fc plus h minus fc over h. And then we have to determine the instantaneous speed, which is vc, and this uses limit, which is limit h to 0 of fc plus h minus fc over h. This function is the basic form of derivative, which is f prime t, or we can also say it is s prime.
This is the example for the question. A beam bicycle moves along a straight line with the equation st equal to t power 3 minus 5t squared plus 15, st in meters and t in seconds. Calculate A, the velocity and acceleration formula. B, the velocity and acceleration when t equal 4. C, at what t does the bicycle stop?
So we got part A for finding the velocity and acceleration formula. That for the first is velocity formula. Velocity is the first derivative of the position. That we know the position is 2t cubic minus 5t squared plus 15. So the first derivative from this position is 6t squared minus 10t. For the next is acceleration formula, where acceleration is the second derivative of position or the first derivative of velocity. So we got the first derivative from position is 6t squared minus 10t. So the acceleration formula is the second derivative from the position. So the acceleration formula is 12t minus 10.
Now moving on to part B, the velocity and acceleration when t equals to 4. When t equals to 4, then the velocity can be calculated by using the function of vt. Thus, v4 equals to 6 times 4 squared minus 10 times 4, and the result is 56 meter per second. And when the t times 4, then the acceleration can be calculated by using the function of at. Thus, a4 equals to 12 times 4 minus 10, and the result is 38 meter per second square.
And now we're moving on to part C. At what t does this bicycle stops? The bicycle will stop if and only if the velocity is 0 or vt equals 0. 6t squared minus 10t equals 0. When we factorizing it, it becomes 2t times 3t minus 5, which give t equals 0 or t equals 5 over 3. Thus, the bicycle will stop at t equals 5 over 3 after moving. That is the application of derivative in real life. In the beam application, we can see our current moving speed. If the beam moves along line with a function of 20x, then the velocity at that moment is 20 meters per second. The acceleration is the first derivative of velocity, which is 0 meter per second squared. This means the beam bicycle does not experience deceleration or acceleration. We can also say that the beam bicycle is moving at a constant speed.
We also have other application of calculus in different fields, such as in engineering, medical, and business. In spaceflight engineering, engineers have to figure out the gravitational pulls of the sun and moon before launching a rocket in order to know how to hit the velocity needed to orbit the Earth. And the next patient diagnosis. Calculus is used to measure cardiac output, blood flow, and tumor growth to assess a patient's health condition. This is an example in a medical field.
credit card payment. Calculus is used to set payment structure and due amount by the credit card company with two variables, interest rate and fluctuating balance. We also use integral to determine the accumulated value if delta or force of interest is known. Structural engineering used to calculate heat loss in building first complex structural configuration and structural analysis and seismic design requirement. Computing birth and death rate. Ecologic is used calculus to make dynamic population model that show the growth of the population. Accurate prediction of population change can be made, which include the birth and death rate.
To conclude, we know that calculus is the study of change, which include limits, derivatives, and integrals. We can use calculus to calculate the velocity and acceleration of a moving formula, and it is so widely used in many fields, turnout, medical, and business fields. Also use calculus. Calculus surely is the basic concept to every field because almost every phenomenon in the universe has a rate of change.
That's all from us.
Thank you.